as well. So this work is going on here at MIT. All right, so let's give one more example of Le Chatelier from a biological perspective. And this has to do with the following reaction. The combination of oxygen with hemoglobin in your blood. And the reaction here, we have hemoglobin plus oxygen has oxyhemoglobin. So the oxygen is now bound to the hemoglobin. This reaction is very important for you. None of us would be alive if this was not happening. We need to get the oxygen from our lungs to our cells. So what happens if you decide to climb Mount Everest, for example? You may be thinking, how hard can that be after a first semester freshman year at MIT? Really? I can think more broadly about it. All right, how many of you have climbed a mountain so far? Whoa, a lot of people. Okay, something about going to MIT and climbing big mountains seems to be connected. How many people feel like after surviving the first year, why not go ahead and climb a mountain? Any more people? Okay, no. Stage 5, you've been through the hard part now. You don't want to risk anything anymore. All right, so this slide seems to be cutting off some stuff, so let's look over here. So what happens to this reaction? Well, as you go up higher and higher, the partial pressure of oxygen changes. So you're going to drop in partial pressure 0.2 to 0.14. So what happens to this reaction if this value decreases? What happens? What direction does it shift? To products or reactants? Right. So if this is going down, then some of your oxygenated hemoglobin is going to release its oxygen. So it'll respond in such a way to compensate for that added stress. Oops. So what can you do to switch it back the other way? Again, we want our blood to be oxygenated. What happens to compensate for this if you're going to climb a mountain? What happens in the body? Yeah. The body can produce more hemoglobin. So you often go to another altitude and hang out for a while before you start going way up. And what's happening during that time is your body realizes there's a problem. It knows about Le Chatelier's principle, and so it's going to make more hemoglobin. And if you add more hemoglobin to this reaction, what direction does it go? Toward products, right. Okay. So I wanted to mention significant figures. And I have to make a confession that when I first started teaching this course, I had never really paid attention to the rules of significant figures for logs. In this unit, the next unit, the unit after, you get the idea, there are going to be a lot of logs. And they have special rules for significant figures. So in the bottom of your handout, these rules are explained. It's also in your book. Pay attention to this. It's going to help you on all the problem sets and in the course. So I just wanted to point out special rules about significant figures for logs. All right. That's it for today. See you on Wednesday.